All right, so in order to find the equation of the tangent and normal lines, we first have to find the slope, which means derivative. So I'm going to start by figuring out what y prime is. So y prime, remember when we're adding, that means just find the derivative of each of the terms individually. So I'm going to find each of those derivatives. The derivative of x is just 1. And then that's going to be plus the derivative of cosine of 2x. Now, since it's cosine of 2x, not just cosine of x, yes, we will have to use chain rule. That starts by doing the derivative of the outer function. That is the derivative of cosine. The derivative of cosine, remember, is negative sine. So instead of writing plus, I'm going to then turn that into a minus to account for the negative. And then that's going to be sine of 2x, because remember, whatever's inside of the function stays the inside of the function. And then I multiply that by the derivative of the inside. So that means derivative of 2x. And the derivative of 2x is just 2. And I'm going to go ahead and tidy that up just a little bit so it's easier to work with going forward. I'll call that 1 minus 2 times sine of 2x. All right, so I found my derivative function. The derivative function allows me to find the slope of the tangent. So let's go ahead and find that slope. I'll call it m sub t for slope of the tangent. I want to put in the t there so I can keep track about which slope it is, because I'm looking for two different equations. I need to keep track of which one's which. All right, so to find that slope, I'm going to plug in my x value of the point that I'm working with here. So we're going to go 1 minus 2 times sine of 2 times my x coordinate, which is 0. All right, so that means that in order to find the slope of the tangent line, I'm going to be doing 1 minus this here. So 2 times 0 is 0. What's sine of 0?
It's not 0.
The sine of 0 is 0. And so it ends up being 2 times 0, so it's actually 1 minus 0 there. All right, and so since the slope ends up equaling 1 minus 0, that just equals 1. So the slope of my tangent line then is 1. All right. Before we go on and find our equations, let's go ahead and find the slope of the normal line too while we're at it. So the slope of the normal line, I'm going to call it m sub n. Slope of normal line. Remember, to find the slope of the normal line is perpendicular to the tangent. So that means the slope has to be the opposite reciprocal. So it's the opposite reciprocal of 1. Opposite means flip the sign, so that makes it negative. And then reciprocal means flip the fraction. If I take 1 over 1 and flip it upside down, it's still 1 over 1. So it's negative 1. So the slope is negative 1, for the normal line at least. All right, now that we know both of those slopes, you can go ahead and find the equation of each of those lines. All right, so now to write the equation of our tangent line, I'm going to plug everything I know for the tangent into y equals mx plus b. So I know the y coordinate here is 1 equals m, so that's the slope of our original tangent line, so that's 1, times x, which is 0 here, because that's the x coordinate of our point, plus b, which is what we're trying to solve for. Notice then, the 1 times 0, that's 0, so that goes away, so we end up just with 1 equals b. So the tangent equation then is y equals 1x, so that's just x, plus 1. All right, next up, let's go to our normal line. And finding our equation is going to work much the same, where I'm going to plug in the points and my slope. So 1 equals a negative 1 times 0 plus b. And again, negative 1 times 0 becomes 0, so 1 equals b. So therefore, y equals a negative 1x, so just negative x plus 1. Notice both have the same y-intercept. Why is that? Because we actually could have taken a shortcut and noticed that the point that we were given here at the start, 0, 1, is on the y-axis. And therefore 1 must be the y-intercept. If you saw that right away as you looked at it, you could use that and go straight to knowing what that b value was in both equations. If not, that's how you do the work to get there. Today we're adding in a new rule into our repertoire of derivatives that we can actually use. So add the material that is inside the box into your notes, and then we're going to see how that actually works in that example down below. All right, so now we want to find the derivative of this f of x function down here to see how this actually works. So we're going to go f prime of x equals, and so notice our rule up here. If I have a to the x, the first thing I write in my derivative is another a to the x. So that's going to be 2 to the x in this case, because 2 is playing the role of a here. But then I have to multiply it by this. Now remember, that means ln a, or in other words, the natural log of a. So that's going to be 2 to the power of x times the natural log of a, which is 2. So it's 2 to the x times the natural log of 2. That is our derivative function. And that is done. Side note here, I try to be in the habit of writing my L kind of cursive. That way it doesn't look like a 1, because I will get myself mixed up because I can't read my own handwriting half the time. If you find yourself in that boat, that's a way to get around confusing your L's and your 1's. All right, now to practice using this rule, we're going to go through these two problems. We're going to do the first one together, so write down that first one, the one on the left, and then having seen how that works, I'll have you do the second one on your own. All right, so to find that derivative, find f prime of x, we have 4 to the power of something with an x in it. So because the x is in the exponent, that tells me I have to use my new exponential rule. So I'm going to have to end up doing that. But I also have to use another rule in this case. What is the other rule that we have to employ? Chain rule, absolutely. Because normally it's just a number to x. If it's not just an x, it's a function here like 3x plus 5, that means chain rule. All right, so chain rule. That means we have to start by doing the derivative of the outer function. Now the outer function here is 4 to the power of something. I use u to represent the something. You can call it 4 to the x if you want, but then that gets mixed up with the other x. So if I'm going to do derivative of that, that means I have to do 4 to the power of that something, so it's 4 to the power of 3x plus 5, times the natural log of the base, which is 4. That's the derivative of the outer function. That's using our new rule that we just learned about. So that was our outer function, 4 to the power of something. But now I have to multiply that by the derivative of the inner function. Now the inner function here is where x would normally reside. Here it's the 3x plus 5. So what's the derivative of 3x plus 5? Yep, it's just 3. And so then this just gets multiplied by 3. Now that's basically our answer. I tend not to like to leave a constant just hanging on the end like that, at least integer 1 like that. So I'm going to rewrite it just a little bit differently. I'm going to write it as 3 times 4 to the 3x plus 5 times the natural log of 4. I like that as a final answer. And yes, you can go ahead and leave it like that. Having seen how that one works, then you can go ahead and do that second one. So go ahead and do the one on the right there on your own now. And then we'll come together and check it. All right, so let's find the derivative of the second now. F prime of x here equals, first up I need to do the derivative of the outer function, because again it's chain rule, because to the power of sine of x, not just x. So that's going to be 5 to the sine of x, so that part all stays the same, times the natural log of the base, so that's natural log of 5, And then we multiplied that by the derivative of the inner function. And again, the inner function is where x normally lives. So that's the sine of x. What is the derivative of sine? Cosine, absolutely. So it's then times the cosine of x. And yeah, I'm going to go ahead and just leave it right like that. That's fine as your final answer like that. If you want to leave it just looking that way. For the last problem we're going through together, I'd like you again to find the equation of the tangent line . All right, now if we're going to find the equation of the tangent line through that point, that means first we have to find the slope, which means finding derivative. So we're going to have to be finding y prime in this problem. But now we have this equation 2x minus 1 to the power of 10. Am I going to have to use the new rule from today, the exponential rule? No, because you'll notice x is not in the exponent. So since this is just to the power of 10, not to the power of something involving x, it's actually just power rule. Power rule and what other rule? Chain rule, yep. Because it's not x to the 10th, it's 2x minus 1 to the 10th. All right, so in order to find the derivative, I do, for chain rule, derivative of the outer function. So that's going to give me 10 times the 2x minus 1 to the 9th using power rule, times the derivative of the inner function. So that's the derivative of 2x minus 1. That derivative is just 2. Now if I clean this up a little bit, that gives me 20 times 2x minus 1 to the 9th. Now that you know that, you can go ahead and figure out what the slope of your line is. All right, so you should end up finding that your slope is 20 here, because when we plug in the x-coordinate from our point that we are given right here, we end up finding that the whole thing just equals 20. Now that you know that, go ahead and write the equation of the line. So that means you got to find the y-intercept now. All right, now for finishing out the equation, we're going to be going back to y equals mx plus b, our basic linear function, and we're going to plug in all the pieces we know. I know that the y-coordinate for my point is going to be 1. So we go 1 equals the slope, which was 20, times the x-coordinate of our point, which is also 1. So 20 times 1 plus b. So 1 equals 20 plus b. Subtract the 20 from both sides. We got negative 19 equals b. Therefore, we know the equation. The final answer is y equals 20x minus 19.